Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. Today's topic is Newton's Law of Gravitation. We know the story that Newton saw an apple falling and then he started contemplating that why the apple is falling towards the earth, why not is going upward. And that led to identification of Newton's laws of motion, which we have learnt in previous videos. So he devised the mechanism that if there is an object near the surface, consider this an apple or any other object, there will be attractive force applied on that object by the earth. Okay, earth pulls the object towards itself. Okay, now Newton's further elaborated that concept and thought about it, whether the force which earth is attracting any object with is applicable only between earth and some object near the earth's surface, or it can be between any two objects. And after further exploration, Newton reached to this understanding is that any object you take, any two objects of mass m1 and m2, then they attract each other. So m1 will be attracted by m2 with say force F12, then m2 will also be attracted with force F21, where magnitude of F12 will be equal to F21, but the direction is opposite in the sense that m2 will attract m1 towards itself with force F12, whereas m1 will attract m2 with force F21 towards itself. Okay. Now, whatever force two objects apply on each other, and with that force they attract each other, that is governed by Newton's law of gravitation. So Newton's proposed, after his elaboration of this concept of two objects attracting each other, is that the force of gravitation, which is attractive force, that force is proportional to the multiplication of the masses of the objects. Okay, so if you double the mass m1, you do it 2m1, and double the mass of m2, that is 2m2, then the force of attraction between these two becomes 4 times. Or if you double the mass m1 and halve the mass m2, then the force of attraction between the two, that magnitude will remain unaltered, right? So that's what his hypothesis was related with gravitation law. He also found that the force between the two objects is also dependent on the distance between these two objects, and it will be inversely proportional to the distance square. So with these two, the force between these two objects, the force of gravitation, will be proportional to multiplication of the two masses divided by r square. Now we also know that any proportionality can be converted into equality with a constant. So the force of gravitation F will be equal to a constant G, and that will be into m1 into m2 divided by r square. This G is the gravitation constant. and it is universal gravitation constant. The magnitude of G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is a universal constant, so it doesn't depend on the medium in which you are operating or temperature and all other. It is universal, and this will be the magnitude of that constant. So in mathematical form, the Newton's law of gravitation is equal to the force of attraction between two bodies is equal to G into m1 into m2 divided by r square. And this is applicable between any two objects. Suppose I'm here and this board is here. I'm also attracting this board with some force. This board is also attracting me with some force, right? But then the natural question will come that why in that case I'm not getting moved towards the board, or board is not getting moved towards me. And the reason for that is that the force of gravitational attraction between the two objects whose masses are small, like my mass and the mass of the board, is such that the force of gravitation is very, very small. And therefore it is not able to overcome, say for example, the friction which my body is having with the earth, and hence I am not moving. Similarly, the force the force of gravitation which I am applying on this board, the board is not able to move because it is heavily and very strongly fixed in the wall, and therefore this feeble force of gravitation is not able to overcome that force, and therefore the board is not coming out. Okay? But the same scenario changes when we discussed about the large masses, like if suppose this is earth and this is moon. Then because the masses are huge, then the force of gravitation becomes very prominent and huge. And force of gravitation is the reason of the movement of the planetary bodies. You certainly know that earth moves around sun. Sun mass is huge, earth mass is also bigger, and then the force of gravitation comes into play between sun and earth. Therefore earth revolves around sun, right? So any such planetary motion, the force of gravitation is the great contributing factor, right? And because of that itself, that planetary motion happens. Now let's think about that what is the correlation between the acceleration due to gravity and the gravitational constant and the force of gravitation. Okay. Now let's consider our earlier example that Earth is attracting a object of mass m, and suppose the mass of Earth is capital M. Okay. So there will be a gravitational force acting on it. From the force of gravitation, Earth will pull this object with force F, which is force of gravitation. This object would also pull Earth towards it, but that force is so minuscule that it doesn't have any material impact on Earth. Also, as we have learnt in Newton's third law of motion, that one body applying force on another body also applies force on the second body, but we have to focus on that body for which we are going to analyze the motion. If this is the mass small m on which we are focusing, then we will just focus on that force of gravitation which is applied by Earth on this body, because this is the only body on which we are going to analyze the motion, not Earth. Okay. Now, F is the force of gravitation applied by Earth on the mass. And with that, this body moves with the gravitational acceleration in downward direction. Okay. Now, if that is the case, then from second law of motion, which is F is equal to m into A, the force acting on this body will be equal to mass into acceleration due to gravity, that is small g. Okay. Now we also know that this force is essentially the force of gravitation through which Earth is attracting this mass. Yeah. So we can comfortably then write that this force is nothing but g times mass of Earth into mass of the body small m divided by the radius of the Earth, because this body is very near to this, so this distance is negligible, so it is almost near to the Earth, and therefore this is the force, which is force of gravitation. And because of force of gravitation, this acceleration g is getting created, and therefore this will be equal to small m into g. Now if you look at small n and small m gets cancelled, and therefore the acceleration due to gravity g becomes equal to capital G into m divided by r square. We know that capital G is 6.67 into 10 to the power minus 11 into mass of the Earth is, as written here, 5.96 into 10 to the power 24 kg divided by radius of the Earth, which is 6.37 into 10 to the power 6 meter square. And if you do all the calculations, you will be getting 9.8 meter per second square. So this is how the acceleration due to gravity near Earth is coming 9.8 meter per second square, and the genesis of that is in the Newton's law of gravitation. Okay. So by now you would have clearly understood what is Newton's law of gravitation, where it is applicable, what is the nature of that gravitational force, how heavenly bodies rotate and their motion is analyzed using the Newton's law of gravitation, why the Newton's law of gravitation is not that prominent when the masses involved are very small, and also how acceleration due to gravity is connected with the Newton's law of gravitation, and why the acceleration due to gravity near Earth is 9.8 meter per second square. Thank you very much.